Hello everyone. In this video, I will go over association rule mining concepts. The applications of association rule mining are very visible. Lots of famous examples such as diaper and beers from Walmart. If customers buy diapers, then there is a higher likelihood they may buy beer than other products. And also at Amazon or on Amazon website, that there are also customers who tend to buy items together or visit pages of different products together. So mainly we was go over some concepts and definitions and continue to uh, also think about some possible applications. So by definition, association or association rules are actually expressed usually using this right ended arrow. On the left hand side is given a set of objects, then the conditions such as the purchase of these objects or the consumption of these projects or the viewing of these objects pages tend to imply the same event of other objects. And so what tie the occurrences of the objects on the left hand side and the objects of the right hand side are what we call events. That given those certain events and group these objects together and based on conditional probability of given this object, then this object also are present at the event. This is how association is derived at a high level. And so the events are, so in association rule mining, the two important concepts are the items such as objects, books, or products on Amazon or in physical stores. The second important concept is the event, such as purchase of the events can be purchases. The events can be online service subscriptions or cell phone or mobile phone service subscriptions. The events can be visiting web pages or web page or can be sessions in which several web pages are viewed or accessed. The events can be students taking courses, doctor prescribing medications, or in biological computing examples can be human or animal genes. They have given certain chemical process and they are expressed at the same level. So events and items. And in the association rule mining algorithms and examples and some implementations out there, the items are called items, the events then tend to be called transactions because the motivations came from purchases a lot. And since transactions usually are also represented by online shopping carts or shopping baskets, so these are also transaction can also be called baskets or the task association rule mining task. Oftentimes is also called market basket analysis. And so here are given the events of purchases, then purchases of a set of items tend to imply the purchases of other set of items. Okay, so other example, the access or visit of pages tend to imply access or visit other set of pages. And expression of some genes tend to imply the expression of other genes. So the events and items are both important or relevant to association rule mining. Lots of decision support, and for marketing, it's allowed this online website design, also for the purpose of marketing or storefront, and online retail, no, in-store retail merchandise placement, online retail catalog design, and also other applications, including fraud detection. I think this is something that we talk a little bit about the importance of exploratory data mining task when labels are very difficult to be obtained. So you can think of that using association rule mining could also help you find if certain things happen, other things tend to happen, and how that could have some implications for some business questions or business tasks, such as fraud detection. And so to talk about association rule mining, even though we don't need to write the algorithm or code the algorithm, we simply apply the algorithm. In this last data mining task that we cover out of our 4 main data mining tasks, similar to others, we'll think about the concepts, understand the concepts so that it will be more meaningful, or the output of association rule mining will be more meaningful. So these are some quick confirmation of the terminology that we have used, but since it's association rule, items over items, so we will use sets of items a lot, starting out with just sets and reviewing that in some notations, such as element is part of, means belong to, and a set is another subset, such as this. So important properties, then when we talk about item sets, these are also sets. So the properties of sets apply. One is that there are no duplicates. So there's no 335 or 355. And if there are the elements actually are in the basket more than once, such as milk, we just represent milk only once. And the overall elements, whether milk first or bread first or soda first, doesn't matter, as long as they are all in the basket and are all unique. We will oftentimes reference the size of the sets, such as size of a item set is 1, then we call the item set 1 item set. The size of the item set is 2, is 2 item set, and that means whether 1 items or 2 items are in an item set. So to perform association rule mining, the input is a set of transactions. Remember, we talk about this is the event that groups a number of items together. So purchases or online or in store. So we'll use some examples to go through measures of association rules and also the association rule mining process. This is an example of 5 transactions. Transaction IDs are here, 1, 2, 3, 4, 5. The dates on 2 days, November 1st and November 2nd. Different customers, altogether 4, and customer 3 purchased twice, one on twice over 2 different days. And these are indicators whether this product has been purchased or not, and it doesn't imply the quantity. And the quantity in the basic quantity of items purchased are not considered in the basic algorithm, Apriori algorithm for association rule mining. That's considered to be an extension. So in many in data mining tasks or statistical analysis, unit of analysis would affect the data and also affect the application. So the most common unit of analysis for association rule mining is a transaction. So that means the items purchased in one transaction. For example, this transaction have these two items, next one, three items, one, three, and then two. These are the input for association rule mining. And so you will consider the association that of buying eggs implies buying milk based on their co-occurrences in a transaction. Remember in the previous example, customer 3 has purchased both of these transactions, transaction 3 and 4. And if we're interested in association between products or amongst products that a single customer bought, then we can change the unit of analysis to customer ID. So there are no changes to customer 1, 2, 4, but customer 3, the transactions, the items purchased in the two transactions belonging to this customer are grouped together, so united or union together. So this one is only one product, and this second one have all three. So this one alone is representative. If you're interested in as a store to see whether on a certain day certain products tend to be bought together often, and could be Monday, Tuesday, Wednesday, Friday, Thursday, Fridays, or weekends, and you can consider grouping by dates. Then these 5 products based on the date information from before the first 3 on one day, the second 2 on second day, then this will show the products purchased on those days. What your objective or your business applications are should should be the basis for choosing this different unit of analysis. So association rules are this is a repeat of that the occurrence or presence or existence of some items during an event together with others can be used to derive association rule that X items in purchase or items in set X imply the purchase of items in set Y, or the event is something else, then will be the co-occurrence of this imply the co-occurrence or the appearance of this. And the way you think about association rule, like X implies Y, is very similar to thinking about conditional probability, that given X has already been purchased or X has already appear in at an event, then what is the probability that Y also appear? And in fact, this conditional probability is an important metric for one of the important metrics for association rule mining too. So here's another example. So similar to other data mining tasks, the measures there are always some measures to measure what is important to this task. In clustering and similarity, the important measure in clustering and k-nearest neighbor, the important measure is similarity. In decision tree, the important measure is measure of disorder or measure of impurity. Here is the measure of correlation of items on the left-hand side of association rule, and the items on the right-hand side of association rule. Okay, so the first metric now is called support. metric. SUPP stands for support. The definition of this is that the ratio of the transactions that contains X, where X is part of this set, like support X and purchasing support of rule X or item set X, and that the support is the ratio of transactions that contain items in X to the transactions or number of transactions altogether in the database. So the total number of transactions in the database. So if the database size is D and the number of transactions that contain X is count X or frequency of X, the formulation is simply dividing this frequency by the total, the size of the database. And so this is essentially also can be interpreted as the probability that this set of the item set X occurs in the transaction file D. So if there are only 100 items in a transaction set of 1,000 transaction contain X, then 100 divided by 1,000 is 10% of chance for X to be in D, and support of X is 10%. So here's an example. This is some format of input to association rule mining that you may often see. The format is called single format for the command read transaction, read.transaction, and means that each row or each instance contains only one item in a transaction. So a transaction that has three items, has purchased three items, will be represented using three rows. And there may be other information associated with it, but this is the item that contains item information, and this is the column contains item information. This column contains transaction information. Using these two columns, then association rule mining can perform the task of deriving association rule. So these are only three transactions purchasing two or three computer-related items. So you can think about how to calculate the support of items that purchase computer and hard disk together in all of these three transactions. If you go back here, computer and hard disk, only this one. No other transactions purchase both of these together. So that's 1/3, 33%. Okay, so you can do some more practice using example like this. So these are 5 transactions, and using these are the 4 possible items. This just indicate whether the items have been purchased or not. Very similar to previous example, but these are egg, milk, bread, and soda. And so if we also look at the support for this single product purchase is 3, 1, 2, 3 transactions out of 5. The support is 3/5, 60%, or 0.6 probability. And these are all of the two combination of two products, so a set that contains two products, and we can sort of code that whether these two products has been purchased in this transaction. So egg and milk both have been purchased, so that's 1. All the others combination of 2 are zeros. This egg and milk also here, but in addition, egg and bread are here, and milk and bread have both of those have been purchased. So this get 1 and the rest are 0. So using this, you can also easily see how many wines out of these 5 transactions have purchased 2 products. Here's 2 out of 5 and 1 out of 5 and also 2 out of 5, none out of 5 and 1 out of 5, and can continue to use this coding for a combination of 3 products, egg, milk, and bread. And this transaction, second transaction, have purchased all 3 and none others. And egg, milk, and soda, none of the transactions have purchased this combination or this combination. And this 3 product is purchased only in transaction 4 and none other. As you can see, when you have more products, then it's less likely that they are purchased altogether in the same transaction. So the support is down to 0, 0 or 20%. And since there's no transaction have purchased all 4 products together, the support for this a set of 4 items it is 0, 2. So now let's talk about the second metric that is important to association rule mining. And the last metric, S, support of a rule, association rule S, was given and discussed previously. And the second metric, confidence, we call confidence C, of abbreviated as a C, and support oftentimes also abbreviated as C. S. Confidence could also be abbreviated as conf and sup and sup. So confidence is also defined for a rule X implies Y. And the meaning of of confidence for this rule essentially is the conditional probability that given X is already in the event or exists, what's the chance that Y also exists in the event, such as purchase in the transaction. And this can be calculated using other formula, but we can also directly use support of items in X on the left-hand side, and the support of items in the intersection of left-hand side and right-hand side, left-hand side and right-hand side of the rule. And using these 2 support measures for 2 different sets, the intersection and the whole X, and the ratio of these 2 essentially is also the same as confidence. You can do some derivation, and both of these have the same denominators, which is the size of the database or size of the transactions. So their numerators are just basically number of transactions containing X and number of transactions containing items that are in both X and Y sets. Okay, so again, confidence essentially is conditional probability that given the left-hand side has been purchased, what's the chance that the right-hand side items are purchased. And the calculations can be taking the percent of transactions that contain both right-hand side and left-hand side. So it has to be both, and divided by the items that are only transactions that contain items only on the left-hand side. So which will be transaction that purchase both egg and milk divided by the number of transactions that contain only eggs. So in another word, out of the transactions that have already purchased eggs, which of those transactions also purchase milk? That's the conditional probability or confidence of X. Egg implies milk. So going back to the example, 6 transactions, sorry, 3 out of 5 and have purchased eggs, but 2 out of 5 or 2 out of those 3 have purchased also milk, meaning milk and egg. And so the confidence is 2/3 or 0.67. So you can go through the rest of the examples for the calculations. And the third metric, which is used oftentimes to evaluate the importance of the rules, and the original association rule mining algorithm didn't apply lift, and modification of it can also apply lift to select rules. But regardless, since we're using the original association rule mining algorithm, and we still use this metric to evaluate the interestingness or importance of association rule. So the metric has a very important name, lift, because by lift it can tend to means that it can enhance the effect. So lift of an association rule, also left-hand side x implies y, is calculated, is also a quantitative measure. It's calculated as the support confidence of which we just defined of x implies y, and we divide this value further by the support of y. So this actually becomes the a division, a different division, becomes a division where the joint probability of x and y appear together divided by the probability that x and y appear independent of each other, meaning their purchases were not promoted by certain new recipes or for food, or not promoted by certain coupon that bundle two products together, and so on and so forth. So this thing is showing that the meaning of this is that the how much how likely that this would appear more than the two x and y may happen independently. So the ratio of probability that x and y occur together, and to the probability that x and y actually occur independently. So when these two are the denominator and the numerator of this ratio is equal to 1, that means that the x and y purchases are totally independent. And so is that interesting? Not, probably not. There's no, it only means that they're not likely to be purchased more often or less often together. And if the ratio is larger than 1, meaning the joint probability that these two happen together are higher, it is higher than the probability that x and y happen independently. So there are some reasons that they are positively correlated, and that reason could be useful to a business or to a task, a data mining task. So identifying and knowing the lift value higher than 1 and which rules have this could be interesting. When this lift value is less than 1, means that compared to the probability that x and y happen independent of each other, the joint probability of x and y happened actually observed are even lower. Which means there's some reason that if if x happens, then y probably doesn't happen often, and vice versa. If y happens and x also probably doesn't happen often, or not necessarily by the same probability, but if X happened, then Y doesn't happen often compared to the probability that X and Y can happen independently. It means there's some reason that preventing Y to happen once X happens. Now, this could also be interesting to an application like healthcare, and to see whether certain health benefits or good health habits, whether there are certain reasons not happening together. And if it's X and Y are both diseases, that if X happens and Y doesn't happen often, that's also good to know. So this is our third measure. So now we talk about the process for deriving association rules. And essentially, association rules uh, have to meet two conditions. One is the support and confidence are higher, are not less than a minimum threshold value of support and minimum threshold value of confidence that are required by the applications or set by data scientists. And to do this seems simple in the example that we saw before, but if it's a large database, it can be very time consuming. So a good systematic algorithm that is time efficient is important. So we will go over the idea of the process of deriving this. And there are essentially two phases. The first phase is identify all of the item sets that have support value not less than the specified minimum support threshold. So if we say we want all of our association rules support to be higher than no less than 10%. So the minimum support level is 10%, 0.1. It means that we want rule to happen probably about 10% of times in the amongst the records or instances. And 10% actually is quite high, and sometimes it's 1%, 5%, 2%, or even a fraction of a percent. And the item sets that have higher value than have support value not less than this minimum support threshold, they are called frequent item sets or large item sets. Frequent or large, large not by the number of items, but by how often they appear. So that's why frequent item sets or large item set. They're called large or frequent whenever the support is higher than a user specified minimum support threshold. So this is the first phase, is to find all of those. This actually is the most time consuming one. And the second criteria for association rules to meet will be a minimum confidence level. So as an example, that we want our association rule to have a support level of 60% or higher, then the minimum threshold for support is 60%. But in addition, for association rules that X implies Y, we also want that there is 80% or more confidence given X that Y will happen. So in the first phase, we only select items and to form item sets that are large or frequent based on minimum support. The minimum confidence threshold level is applied in the second phase to examine all the combination of items in large item set, that if they are on the left-hand side or right-hand side, so given there's an item set L and we take a part of the item, say A, to be on the left-hand side, the rest of the items on the right-hand side, then we know the items in this rule has support that is higher than the minimum support, and that is what is required for this rule. But we don't know whether the confidence is high enough. That's in this phase, that's when we calculate the confidence for this rule and for all possible combination of each item set for all of the item sets that are generated here. So you can see that for large data set and for very low support threshold and confidence threshold, we could easily generate a very, very large number of item sets and therefore rules, because this becomes combinatorial. But if you also set very, very high support threshold level and very, very high confidence threshold level, then you may not be able to find any item sets or any rules that meet this combination. So as a data scientist, that deciding on the minimum support level and minimum confidence level is part of also an exploratory process that going through empirical experiments and also thinking about your application. And so it's a trade-off of those two. So now the main algorithm that has made association rule mining famous, in addition to diaper and beer have made association rule mining famous, is called Apriori algorithm. This particular algorithm actually is not named after the authors, but after a property that is very important to this algorithm, or the algorithms based on this property. The two authors, Srikant and Rakesh Agrawal from IBM in the early 90s, late 80s, they were the main developers. They continued to develop some extension of this, and Rakesh Agrawal actually in the mid 2006 or 7 moved to Microsoft to serve a very, very important role for Microsoft. So data scientist has important role to move to, important career to move on to. And so the a priori property is related to item sets only, and the a priori property is mainly used for the first phase. So one thing I wanted to let me back up here to point out one thing is the most time-consuming part is actually this phase before this. This is more systematic and only going through all the item sets once. And this one will go through the transactions possibly over and over, going through iteration. So this one is time consuming. And so the a priori property is defined using the concept of large item set. So if we remember, a large item set is a set of items whose support meets the minimum support threshold. For example, previously 60% is the minimum support threshold level. Then we know that if an item set, say ABC, or egg, milk, and bread, of the 3 items in an item set is considered to be, this set is large, then we know that this appears 60% or more often in the transactions or in the data set. So a priori says that a subset of such an item set, any subset of this, also must be large, meaning there are also large item sets. A subset of egg, milk, and bread can be just a set of milk. So if egg, milk, and bread appear 60% of times in a transaction, then egg must have also appear 60% or more. Otherwise, egg, milk, and bread cannot be in 60% of the transaction. And a subset can be only egg and milk. And given that egg, milk, and bread already are in 60% of transactions, of course, egg and milk must be in 60% or more transactions. So by definition, those smaller item sets out of a large item sets are also large, meaning they happen 60% or more often, or happen not less frequently than the support threshold level. Okay, so the algorithm can be explained using an example. So this is an example of, again, 5 items, and this is a basket format of input to a priori algorithm, where the items represented by, for example, item IDs are listed. Only the ones that are purchased are listed, so their variable length or variable number of items, so 5 for 2 only and 4 for here. This is the market. Each row is still a whole transaction. And so this is an example, another example of the a priori property, like the item set 2, 3, and 5 has appear in this and this 2 transactions. Since the minimum supports only 40%, and so this is, by definition, this is large. And any subset of this 3 could be, of this 3 item set, could be single item sets, 2 item sets. They must be large, which means they must, their support must be 40% or higher. So you can see 2 appear 3 times, 3 appear 3 times, 5 appear 3 times also, then 2, 3, 2 times, and 2, 5, 2, 5, and 2, 5, 3 times, and 3, 5, and 3, 5 appear 2 times. 2 or 3 all high enough. Okay, so the steps of a priori algorithm can consist of the following: initialization first. Input the database and going through all the transactions once and find all the large 1 item sets, and so meaning single item set. And that's the whole idea is build the large item sets from small to large, from a smaller number of items to larger number of items, incrementally by 1 more at a time. So we start with building, identifying all the 1 item sets, so all the single item sets that meet the minimum threshold level, 40%, for example. Then we start to generate the next larger, set of item sets that have 1 more items in each of the item sets. So start with 1, then next we will find possibly could be large 2 item sets. And then we will evaluate the support values, and then narrow down the the 2 item sets that are actually large. Then we start to merge 2 item sets, so 2 sets. Each one of the 2 has 2 items, and when if we the 2 of them have 1 overlapping element, then we can merge the 2 into 1 3 item set, and then we will evaluate whether it has a high enough support level, and this is what this does, is that once we have the candidate item sets, then we will evaluate whether it has high enough of support level, and go through these iterations until there are no more candidate item set that has 1 more item than the previous large item sets. So we start with building 1, finding all the large 1 item set, then all the large 2 item sets, then all the 3 large item sets, then the 4 large 4 item sets, And if there's no more for large item sets, then we stop. Oh, so this is the the loop and the main part, and we can go through the examples to see the efficiency, that why we only increase the large item sets by one more item in a set at a time. Okay, so the steps are, after we have the initial large one item sets, then we want to create two item sets. So k item sets. When k equals to 2, then we just want to create two item sets. And for 2 is easy. We just combine every pair of unique one item sets into a new two item set. And then we evaluate whether they are large. And once they are large, the ones that are large to item set will start to go into the rest of this loop. So by the time you come here, then we are trying to create three item sets, like k equals to 3 or 4. And we start out with the large two item sets, and we'll combine two large two item sets, for example, that have one common element. And for efficiency, we avoid duplicating checks, we will sort them and just identify the identical first element, and then we just combine the last two last elements that are not identical. So one identical amongst two item sets. So L1 1 and L2 n means these are the first element of set L1 and the first element of set L2. When these two are equal, means these two sets have the same first item, for example, X. And so two item sets have one common item, and the other two elements are not the same. So by merging these two together, you get three item set. Then we will estimate the size, estimate the support level, calculate the support level of the possible three item sets, and then evaluate and whether it meets the minimum support threshold level, and keep only the large 3. And then we'll come back to generate large 4, candidate large 4, and evaluate whether candidate large 4 become large 4, and the large 4 will come back here to generate candidate large 5 item sets, and so on and so forth. So going back to this example, and minimum support 40%, minimum confidence 70%. So to input, we start out with this 5 transaction and going through 10 possible one item set. Each one has item 1 or 2 or 3 or 4 and 5, 6, 7, and so on. And after evaluating the support, the large one item sets are narrowed down to 1, 2, 3, 4, 5, that, which appear 3 or 2 times out of 5 transactions. And the minimum support is 40%. So these are large one item set. And remember, from large one item set to generate generate candidate, possibly large two item sets, we just take every unique combination of 2. So 1, 2, 1, 3, 1, 4, 1, 5. We will not include 6 here or include 7, 8, 9, 10 because they were not large. And the reason is the a priori property, that if 1, 2 will eventually be large, then 1 must be large and 2 must be large. So since 6 or 7 are not large, we will not consider 1, 6 because 6 it was not large. So 1, 6 can never be large. So with this combination, we go back and calculate the support level, and these are the only remaining large two item sets that appear in 2 out of 5 transactions or 3 out of 5 transactions. And now given this, now 5 2-item sets are large. Now we want to generate possibly large 3-item sets, candidate large. So now this is where we need to give it a little bit thought of, make sure they're sorted, so for efficiency, so we're doing this systematically. So we just only need to compare between 2 sets, that if the first item is identical, and in this case this 2 is, then we merge these 2 sets by, since we cannot duplicate this, one would appear only once in the new set, and the other elements from these 2 sets will be included. That becomes 3. And this will also be merged 2, 3, 5. And we will not do 1, 3, 5 because actually eventually we'll know that that they will also not be large. And that's the beauty of doing this sorting, and can increase efficiency too. Okay, so this 2, based on the support calculations, 2 out of 5 is still large, but because this is the only large 3-item set, there's no other large 3-item set can be used to help create candidate 4-item set. So we have found all the possible large item set up to 3, and no more large possible after 4. So association rule mining terminates. So even though you don't have to code this process, going through this example can cement the idea of the meaning of large item set and how they are created. And remember using this large 3 and large 2 item sets, but not large 1 item sets, because to create association rules, you must have left-hand side, right-hand side. So the minimum number of items on the left-hand side or right-hand side of a rule will be 1. So you must, can only use large 2-item sets and large 3-item sets to create association rule of giving purchase of 2 also implies purchase of 3 and 5, or giving purchase of 2 and 3 implies purchase of 5, or giving the purchase of 3 and 5 implies purchase of 2. So you can do it in any order of the combination. Lots of extensions from association rules that we will not go into there. Extensions are not that complicated, such as if we count the quantity of how many eggs or how many dozens of eggs have been purchased, and how many loaves of bread are purchased. These are quantitative association rules, and this also consider similar different kind of quantity information. This one, sequential patterns, is actually a very, very popular, also involved original 2 authors of association rules. And this is talking about if someone bought this earlier, will also buy something later. And this have a lot of both marketing applications, and actually very famous that this have been used for intrusion detection type of applications. Oh. So the package that you will use for association rule is a rule. And actually, I'm more familiar with the ones that are in Awaka. But after have given you more packages than the book introduced for most of the data mining task, and for association rule, we'll stick to a rules. It's very widely used. And so the format that you will use is a basket format to get input data. And in your tutorial, the code is from chapter 8 of machine learning with R. And the format is basket format. The data set is this. For your assignment 7, I have derived the data set from your NS data from social network teenagers profile keywords. And for this, because if you think about it, so if some if teenagers tend to use these certain words, do they how often they will also use other words? So I think that will be a useful, exploratory, and potential good business task as well. Thank you.